Hello and welcome back to our next science lesson, and today we are continuing to look at materials and their properties. This week we're going to be focusing on understanding thermal insulators and conductors. So the actual question for today that we're going to try and ask is whether I understand what a thermal insulator is. Now, in order to answer that question, we need to know what a conductor and insulator are and what the words mean. We also need to think about making a prediction using our existing knowledge. Now, we thought about this before when we were looking at all our other investigations. And the reason we keep coming back to this is every time that we come to do a little test like this, we want to think about using those scientific skills and how that works across the board. This is called working scientifically, and it feeds into our thinking in every science lesson that we do. We're also going to carry out an investigation which have a look at the effectiveness of thermal insulators. So, do we know what the word conductor and insulator mean? To conduct means to allow heat or electricity to travel through the material. For example, if you were to heat one end of a metal bar, the heat would be conducted along the metal and you'll burn your hands. So if you've got a heat source, you put something into the heat source. If it was a conductor, you would start feeling the heat traveling through that material. Now, some materials are better at that and some materials are worse than that. And a conductor is a material that does that well. So although we're looking at heat today, this is also the same case with electricity. On the other hand, we have insulators, and insulators don't allow heat or electricity to travel through them. They stop that being passed through them. For example, if you wear a winter coat, it insulates you and keeps your body warm by trapping the heat inside. So it stops the movement of heat from your body to the outside air. Now, this is important because what insulators do stop it from traveling one side to the other side, or reduce the amount traveled from one side of the insulator to the other side. But it works the same both ways. So if it was hot outside and you wanted to be warm inside, if you had an insulator between it, it wouldn't travel through, whereas with a conductor, it would. Again, this is the same with electricity as it is with heat. So our homes are insulated, and this is to help keep the heat in and save us money and energy because we don't have to keep heating our houses. Whereas if they weren't insulated, we'd lose a lot of heat and therefore have to keep reheating the house in order to stay warm. So they put insulating in the roof spaces to trap heat in, and also in the walls to trap heat in. And this is done in lots of different ways. So you can see two different ways here. You get insulating board. You can have foam insulation in cavity walls. There's lots of ways of insulating, but the idea is the same. What you're trying to reduce is the amount that the heat is transferred from inside to outside. And this image shows that really well. So this image is taken using a thermal camera. And the brighter the colours, so the closer to red and white that they are, the more heat is being lost, or more heat is there coming out from that point. Whereas the closer they are to dark blue, the less heat is escaping. So this is a really good image because the house on the left here shows a lot of blue areas. Yes, there are some yellow areas, and we can talk about where they are. But actually, there's not a lot of heat coming out of the house. Whereas on this image here, you see a lot of reds and yellows, which means a lot more heat is escaping. And this is due to the difference in insulation in the two houses. The house on the left here must be well insulated. It is keeping the heat in. Now we're losing a little bit of heat through the doors and the windows where you don't have as much insulation. Whereas in this house here, yes, we've got heat escaping from those three places, the doors and windows, much like we did on the other house, but they're higher, so there's no insulation at all. But also through where the walls are, we're losing heat, which is probably where the insulation hasn't been taken as well. Even through the roof up here, you can see this is nice and dark blue, whereas this is yellowy green over here. So it's just the reduction. There is some reduction, but not a massive amount. So this house is losing heat a lot more than this house here is. It's a nice, easy way to see it. Now, some materials allow heat to travel through them easily, and these are conductors, whereas some don't allow them to, and they are insulators. Both of these properties are important for different objects. So what you want to think about is, when is an insulator useful and when is a conductor useful, and when do we want to use one or the other? So I know that a lot of you at home are helping out around the house, and some of you may be helping out in the kitchen. Well done, you. So let's think about the pan. We need the main part of the pan, the bit what we're cooking on, to be a conductor. We need the heat to travel from the hob to whatever we're cooking inside our pan to reach the food. So the pan needs to be a conductor. And most often these are metal, because metal is a good conductor of heat. Whereas if the whole of it was made out of metal, we'd have a problem trying to grab the handle, because as soon as we grab the handle, the heat would be transferred up the handle. We'd feel it in our hands and probably burn our hands. So in this case, we need the handle to be an insulator, which is why the majority of manufacturers use a strong plastic for this, so that when we touch it, we don't burn our hands. It might be slightly hotter, but it won't be to the same degree as it would if it was metal. So, what type of materials make good thermal insulators? Or what materials keep heat in? We're going to look at how we might do an exploratory investigation into materials that you have in your kitchen or around the kitchen, that what they might be made of and how good they might be at insulating heat. Now, this is a heat experiment, and we're going to use hot water. So it's really important that you have an adult around to help you set up with this, so that you don't burn yourself or scald yourself. Please, please, please be careful, but it's a really nice experiment to do to see the effects of an insulator. Now, your task: find a selection of containers of different materials. So you might have a mug, a glass, a pan, and a plastic Tupperware or something similar. Now, if you're going to choose these, if some of them have lids and some of them don't, can you make sure none of them have lids? What you don't want to do is be testing if you've got them open, leave them all open. If you've got something to go over the top of them, make sure there's something to go over the top of all of them. This is only so that what you're imagining is, if you've got something over the top, you've got something keeping the heat in there as well, whereas some are open, more heat will be lost that way. So you're not testing the ability to insulate from the material, because you've also got a lid on. So your task: carefully pour hot water into each of the containers, so they're roughly about a half full. Now, this is why it's an exploratory investigation, because your containers are going to be different sizes. It's not completely fair, because you can't make all your containers the same size. If you all had the same size containers in different materials, then it'd be different. But in this case, because they're made out of something different and they're going through different sizes, it's only an exploratory investigation. But it will still give us some useful information. So predict. Make your prediction based on what you already know as to which of those containers will keep the water warmest the longest. And you can bring in information from anything. Just think about what you know, what you use those materials for, to help you understand which one you think might be the best insulator. Now wait. After about 10 minutes, go back and carefully feel the outside of the containers and just see which ones kept the water the hottest. If you have got a thermometer, you could of course use that to see, but if you haven't, just judge temperature by your hands or touching the water if it is cool enough. It should be after 10 minutes. And then rank materials from the best insulator, so stayed the hottest, to the worst insulator, the one that's cooled down the most. And then create a clear table of results. got a container on one side, so maybe a mug, what material it's made out of, clay, plastic, metal, glass, and then rank it first, second, third, fourth, however many different materials that you are testing. And that should give you an idea of which one was the best, the worst. Nice and easily. You can even see the ones in between. Now, remember that this is an exploratory investigation, so it's not necessarily going to give you spot on results or make you have really accurate results because you're just testing the general field, but it does give you an idea. Thank you for listening. Enjoy the lesson, and we will see you in the next lesson. Goodbye.